signal, right? Okay. All right. We're going to talk about what a derivative is and how it relates to calculus. So I'm going to take an arbitrary curve. My handwriting's not too good, of course. Never was. But I write bigger to compensate. Okay, so I'm going to take a curve, right? And what happens in this curve is that I'm going to take a point here and a point here, and I'm going to look to find the slope of the secant, which is the line that goes through these 2 points. All right, so that's usually m equals y2 minus y1 over x2 minus x1. All right, so that's going to be the slope between those 2 points. Now, what would happen if my main objective here is to find the slope of the line that's tangent to this point? Well, that seems almost impossible to do because this formula right over here needs 2 points. And here we're talking about just 1 point. So what do? You get a little bit closer, right? And you find the slope of this secant. And as you can see, it's going to get closer to the slope of the tangent line, which would be the slope of this writing utensil right now. So basically what's going to happen is you're going to take the slope of the secant line, get a little bit closer, a little bit closer, and a little bit closer. And if you can find a limit of what slope that's approaching, well, that's going to be the slope of the tangent line. It's also called the instantaneous rate of change, and it's also called the derivative, hence calculus. So how do you do that? You have x, right? That's an arbitrary point, and we go h units away, x plus h. So this point here is x comma f of x, right? And this point up here is x plus h comma f of x plus h. So to find the slope, okay, of the secant line, I'm going to use the formula, and it's simply going to be slope is equal to, I'm going to put this over here because I'm going to do something in between in a few minutes. I'm going to get f of x plus h minus f of x. Okay, that's y2 minus y1 over x2, which is x plus h, minus x1, which is x, right? So what happens now, we get the limit of f of x plus h minus f of x over h. Well, let me change this up a little bit. Now that's simply the slope of any point that's h units away from x. But as before, what happens, okay, when we start to move this point closer to the point where we like to find the slope of the tangent line, which in reality is an instantaneous rate of change of the change in y over the change in x. This is the change in y, this slope right here, okay, from this point to this point. But we want an instantaneous rate of change right at this point. So what will happen is we will take the limit, okay, of this. All right? So what happens is h goes to 0. As it gets smaller and smaller, we're going to get the slope of the secant line. The slope of the secant line is closer to this point. As this point moves down, we're going to get the slope of another secant line, all right, until we can actually find what the limit is, and that's going to be called the derivative. And that's equal to f prime of x, and that's what calculus is. So that's a real important concept, and we could show it with an example, which we'll do later, but for now, this is what a derivative is. And keep in mind a couple things. A derivative is an instantaneous rate of change, and it is also the slope of the curve. All right, so thank you for being here.